Intermediate Algebra Homework, Day 23, starting Chapter 4. Starts out with simplifying something like x times x to the fourth times x to the third. If we think about what an exponent means, x to the fourth power means you have an x times an x times an x times an x. You have 4 x's on your list. So if I expand in this whole thing out, I'm going to have x times my x to the fourth, x times x times x times x times my x to the third, x times x times x. And if I follow my rules for exponents, notice that I have all x's. I've got 1, 2, 3, 4, 5, 6, 7, 8. So I could combine all of that. X times 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 x is x to the 8th power. This leads us to the rule when you're multiplying with the same base, what you're going to do is add the exponents. This is x to the first, so if I take 1 plus 4 plus 3, I get 8. So in algebra, on their rules, they're going to show you something like this. If I have x to the m times x to the n, I can combine it into x to the m plus n. When I'm multiplying with the same base, I add my exponents. So number 2 says we're going to take w to the third times w to the fourth times w squared times w. Basically, I'm just going to add my exponents then. I've got 3 plus 4 is 7. 7 plus 2 would be 9. 9 plus 1 would be 10. So I'm going to get w to the 10th power. 3 plus 4 plus 2 plus 1. Don't forget about the w as being w to the first power. So when I do the third one there, I'm taking y times y to the 5th. Y times y to the 5th, 1 plus 5, y to the 6th power. So when I multiply with the same base, I add my exponents. So now they're going to use that to simplify longer expressions. If I can get my board to work so I can erase the board. There we go. And so now we're going to do multivariate expressions. 2y to the 5th, v to the 5th, times 4v to the 4th times 6y. This really means 2 times y to the 5th times v to the 5th. Times 4 times v to the 4th times y to the 6th. I could have little dots in between each of those, but I want to just realize that each of these are separate expressions. When I'm going to multiply, I'm going to multiply the like things together. So I'm going to rearrange this. I'm going to take the 2 times the 4 times the 6. 2 times 4 times 6. Then I'm going to group my like variables together. So times y to the 5th and times a y. Y to the 5th and times a y. Times v to the 5th times v to the 4th. V to the 5th and v to the 4th. So we have that commutative property that says we can change the order, and now I'm going to multiply these together. 2 times 4 is 8. 8 times 6 would be 48. Here I follow my rules. When I'm multiplying with the same base, I add my exponents. 5 plus 1 would be y to the 6th. Y to the 5th times y, y to the 6th. V to the 5th times v to the 4th, I add, I get v to the 9th. So 48 y to the 6th, v to the 9th would be my answer. So number 5, basically we're doing the same thing. 2w to the 4th y cubed times 2y to the 7th times 5w. Rearranging that, I'm going to do 2 times 2 times 5. Then w to the 4th times w, and y to the 3rd times y to the 7th. So 2 times 2 is 4. 4 times 5 would give me 20, multiplying my coefficients together. W to the 4th times w, 4 plus 1 would give me w to the 5th. Y to the 3rd times y to the 7th. 3 plus 7 gives me y to the 10th. So 20 w to the 5th, y to the 10th would be my answer. Go ahead, try that next one while I'm clearing the board. So number 6, if you're going to multiply that one, hopefully you did 2 times 4 times 6, and then you have a y to the 5th times a y to the 6th, and a u times a u to the 5th. And the order of those variables could be reversed if you did your u's before your y's, that's fine. Multiplying that out, 2 times 4 is 8, 8 times 6 is 48. Y to the 5th times y to the 6th. I add my exponents, I get y to the 11th. U times u to the 5th, again I add my exponents, so u to the 6th power. So 48y to the 11th, u to the 6th. Now 7 is trying to get you to compare expressions, and they want you to get used to some of the rules. We already had the rule if my bases were the same, x to the m times x to the n, I add my exponents, x to the m plus n. They're also going to give you the rule that if my exponents are the same, if I have x to the m times y to the n, oh nope, I want to use n. My exponents are the same. So x to the m times y to the m, you're going to get x times y to the m power. So I multiply my bases and keep that exponent. So looking here on this one, I have 2 squared and 4 squared. My exponents are the same, so my rule is to multiply my bases. 2 times 4 is 8, and I keep that same exponent. So I'm going to get 8 squared. 8 squared compared to 8 to the 4th, going to be less than. Here, on this one, this is the one where my bases are the same, like we did up here. 2 to the 4th, 2 squared. My rule is to add those exponents. So 4 plus 2 would be 6, so I would get 2 to the 6th power. 2 to the 6th compared to 2 to the 8th, going to be less than. Now on this other one where you don't have a common base and you don't have a common exponent, basically you just have to figure it out. 2 to the 4th is 16. 4 squared is also 16. Well, that's going to be 16 squared. 16 squared compared to 8 squared, well, 16 squared is definitely bigger than 8 squared. You could even go farther than that if you wanted to use your calculator and figure out what 16 squared is and what 8 squared is. I got to grab my calculator quick here. So, 16 squared would have been 256, and 8 squared would have been 64, and yes, we know 256 is bigger than 64. So basically on that bottom one, you just have to do your calculation until you can tell which one's bigger or which one's smaller. On the other two, they're going to be using one of these two rules. If my bases are the same, I add my exponents. If my exponents are the same, I multiply my bases and keep that exponent. So number 8, I'm looking at that. I have 2 to the 3rd times 2 squared. My bases are the same. My rule is to add my exponents. 2 to the 3rd times 2 squared would be 2 to the 5th. 2 to the 5th is going to be less than 2 to the 6th. On the next one, my exponents are the same. If my exponents are the same, I multiply my bases. 2 times 3 is 6, and I keep that exponent, so I'm going to get 6 squared. 6 squared compared to 6 squared, going to be equal. The next one, 2 to the 3rd power, 3 squared, neither are the same, so 2 to the 3rd is 8, 3 squared is 9, 8 times 9 is 72. 6 to the 6th power, I don't know what it is in my head, but I know it's going to be really big. 6 times 6 times 6 times 6 times 6 times 6. If I got them all in there, I've got 46,656. Obviously 72 is going to be less than that. Should use my other calculator where I have my exponent key instead of having to do it the long way. 6 to the 6th power. The next one here, I've got 3 to the 3rd and 5 to the 3rd. My exponents are the same, so I multiply my bases. I would get 15 to the 3rd. 15 to the third is going to be less than 15 to the fifth. On this one, my bases are the same. 3 to the fifth and 3 to the third. If my bases are the same, I add my exponents, I get 3 to the eighth. 3 to the eighth compared to 3 to the 15th, going to be less than. And then here's another one where I just basically have to calculate that out. 3 to the fifth is going to be 243 times 5 to the third. 5 to the third is 125. 243 times 125 is 30,375. On the other side, I'm going to do 15 to the third power. 15 to the third power is 3,375. So we can see that 30,375 is greater than 3,375. And really on all of these problems, you could do the calculations and compare your two answers. They're just trying to give you a shortcut where you don't have to do all the multiplying out and figure out what the numbers are by either, if my exponents are the same, multiplying my bases, or if my bases are the same, adding my exponents and giving you a little shortcut. Number 10, we are going to square 9y. If I square 9y, I'm going to do a 9y times a second 9y. That's what squared means, times itself. So I'm doing 9 times 9, which is 81, and then y times y, which is y to the second power. So my shortcut here is what I'm doing is I'm going to take the 9 and square it, and then I also have to take the y and square it. 9 squared is 81, y squared obviously stays y squared. So if I'm going to do 2x to the fifth power, I could do 2x times 2x times 2x times 2x times 2x. Gets really long. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. And I've got 1, 2, 3, 4, 5 x's, so x to the fifth power. However, if we do our shortcut, we would take the 2 to the fifth power and then the x to the fifth power. 2 to the fifth power is 32, and then x to the fifth power, and I get the same answer either way. Now, obviously, the second way is a little bit shorter than having to write it out 5 times, and so on number 12, if we do it, taking 3w, raising it to the fourth power, I'm going to take the 3 to the fourth power, and then the w to the fourth power. So 3 to the fourth power, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. Then I'm going to have w to the fourth. So if I take 3w and I raise it to the fourth power, I get 81w to the fourth. Number 13 and 14 and 15, same kind of thing. Doing it the long way, if I were going to square it, it would mean that I'm taking 3w to the fifth y times a second, 3w to the fifth y. So I'd be taking 3 times 3, which is 9, w to the fifth times w to the fifth. I add my exponents, so w to the 10th, y times y, y squared. If I use my shortcut, I'm going to do this. I'm going to take the 3 and square it. I'm going to take my w to the fifth and square it. And I'm going to take my y and square it. 3 squared, I do the normal way. 3 times 3 is 9. Now here's the new rule that we haven't had yet. When I raise something to a power, notice when I took w to the fifth times w to the fifth, I added my exponent and I got 10. Well, the shortcut here is when I raise to a power, I can just multiply those two exponents together. W to the fifth and w to the fifth, I've got 2 of them. I end up with w to the 10th power. And then I have a y squared, so y squared. So they're going to say that I have x to the m raised to the nth power. I get x to the m times n. I multiply those exponents as my shortcut. So number 14, if I have negative 2uv cubed and I'm raising it to the fifth power, I'm going to do the negative 2 to the 5th power, the u to the 5th power, and then the v to the 3rd to the 5th power. So negative 2 to the 5th power. If you're using your calculator, by the way, make sure you put the parentheses so that you don't have a sign mistake. This one will have an odd exponent, so it will end up being negative, but if it's even, it turns it to a positive. So make sure if you use your calculator, you use the parentheses. Negative 2 to the 5th power happens to be negative 32. Here I have u to the 5th power. And then here I have v to the 3rd raised to the 5th power. My shortcut is that I can just multiply those exponents. 3 times 5 gives me v to the 15th. Because I do v to the 3rd, a v to the 3rd, v to the 3rd, v to the 3rd, and v to the 3rd. 5 of them would give me 15. So number 15, same kind of thing. I'm going to square this. So I'm going to take my negative 5 and square it. I'm going to take my x cubed and square it. And I'm going to take my y to the 4th and square it. So if I take my negative 5 squared, negative 5 times negative 5 makes that positive 25. Then my rule here, if I raise it to a power, I multiply those exponents, so I get x to the 6th. Raising to a power here, multiplying my exponents, y to the 8th. So I get 25, x to the 6th, y to the 8th. (16, 17, and 18, same kind of thing. We're just having that fraction in there. But I'm going to do the same thing. I'm raising to the 4th power. So I'm going to take my w squared to the 4th power. I'm going to take my 2 to the 4th power. And I'm going to take my u to the 4th power. So when I raise to a power, I multiply those exponents. I would get w to the 8th. 2 to the 4th power, 2 times 2 times 2 times 2 happens to be 16. And then here, I multiply my exponents again. 4 times 4 is 16. So I get w to the 8th over 16u to the 16th power. 17, same kind of thing. I'm taking negative 3 and I'm going to square it first. Then I have a v that I have to square. And then on the bottom, w to the 3rd that I'm going to square. So negative 3 times negative 3 would give me positive 9. Then I have v squared. On the bottom, w to the 3rd squared. I multiply my exponents, so w to the 6th power. So 9v squared over w to the 6th power. So number 18, same kind of thing here. I'm raising to a power, so I'm going to take v to the 3rd and square it. I'm going to take my negative 3 and square it, and I'm going to take my u squared and square it. So on the top, I'm going to get v to the 6th. On the bottom, a negative 3 squared is a positive 9, u to the 4th. 2 times 2 is 4. The next ones, we're simplifying fractions, and in this case we're thinking about canceling things out. So again, if I do it the long way to explain what my rule is, u to the 6th means I have u times u times u times u times u times u. 1, 2, 3, 4, 5, 6 of them. Then I have times a w. On the bottom I have u to the 3rd, u times u times u, and w to the 4th. w times w times w times w. So we know that with fractions, when it's written in factored form, we can cancel out the common factors. So u goes into there once and into there one time. U goes into there once and into there one time. Usually we don't write all those ones, but for effect I'm going to. I've canceled out 3 of my u's. I can also cancel out 1 of my w's. I'm just going to do the end one. So what I have left is u to the 3rd on top and w to the 3rd on the bottom. Well, instead of having to do that, what we're really just doing is subtracting. When we reduce down, we're going to subtract our exponents. So 6 minus 3 is going to give me u to the third. Here, I'm going to take the 1 away from the 4. 4 minus 1 is going to give me 3. Notice when I subtract, my exponent ends up being where the variable is larger. So, my rule here, if I have x to the m over x to the n, I'm going to do x to the m minus n. And I want to take the small one away from the big one, leaving my variable where it's larger. So on number 20, if I have b squared over b to the fifth, the b squared is smaller. That means I'm going to take out 2 of my b's. That's going to be gone. 5 minus 2 means I'm going to have b to the third. Here, I have a squared and a to the third. Again, the a squared is smaller. I'm going to take out 2 of my a's, means I don't have any a's on top. 3 minus 2 means I have 1 a down on the bottom. Now, I have to be careful when I write this answer. I have a b cubed and an a on the bottom. There should be something on top of that fraction. That's why I go back to thinking about this. When I canceled, I had 1, 1, 1. So I'm going to have a 1 up there on the top. So I get 1 over b cubed a. And one last one on this one. If I'm going to simplify this, I'm going to reduce this down. The 3 isn't going to do anything because there's nothing to reduce it with. I have an x to the 6th over an x to the 4th. I'm going to take out 4 of them, which leaves me an x to the 2nd up on top because 6 is bigger than the 4. Same thing here. I have a y squared over a y. I'm going to take out 1 of my y's, leaves me the extra y on top. So I would have 3x squared y over 1, which just is 3x squared y then for my answer. So if the one's on the top, you need to have it there, but if the one's on the bottom, we don't need to write it there.